And then I have one on the back for you as well.
Let's do 4. A variable j varies. What does that mean? How do I translate the word vary?
Was it like mx or something?
No, it means equal. In other words, j is equal is what it means. The first 4 words of that sentence. A variable j varies allows me to write j equals something. Jointly, meaning the next 2 variables that I'm looking at are going to be multiplied together.
Yeah.
Here's the thing. On all of these varying problems, there's a k. That's the first thing you want to write is k. There's always a k, and it's always in the numerator. Okay? Now, it varies jointly as the square of h, which that looks like that, and as the cube root of a. The cube root of a. And it varies inversely with s. So that's how I write that. Okay? In other words, all of that I can write just by knowing what varies jointly and inversely.
That helps quite a bit.
It does. You have to be able to do that first part. In other words, you can't do anything with the problem unless you can write this equation down. This equation is what that first sentence says. Now, it says, what happens to j when h is doubled? Oh, okay. When h is doubled, a is multiplied by 8, and s is multiplied by 4. Well, if a is multiplied by 8, it becomes the cube root of 8a, right? In other words, let's just write it as they're saying. When h is doubled and when a is multiplied by 8 and s is multiplied by 4. So, what is the difference between these two expressions? Well, here, let's solve it, and we'll be able to figure it out exactly. In other words, I'm going to write the second one and see how the two compare. Okay? Well, this becomes k times 4h squared. You with me?
Yes, I am.
Cube root of 8 is 2. So I'm going to remove that 2 and have cube root of a. Like that. And then 4s. Well, I can see that the 4's cancel.
Oh, I have a question. Why isn't it like the cube root of 8a? Why isn't that just 2a?
Well, because it was 8. So here, let's go up here at the top. If I have the cube root of 8a, that is equal to the cube root of 8 times the cube root of a.
Oh.
And the cube root of 8 is 2.
Yes, sir.
Okay. So here's what I get. My 4's cancel. I now have k h squared. I'll put that 2 out in front like that. I still have the cube root of a, and I have s there. Well, how does that compare to this up here? What's happened to j?
Well, j has increased by It's doubled?
Doubled. Exactly. It's doubled. In other words, the difference between those two terms, this term on the right is twice as big as the term on the left, which means J is twice as big.
J is doubled.
Unless I made a math error, and I don't think I did. I think all of this is correct, yeah.
Gotcha.
Okay. What was the next one you wanted to look at?
I wanted to look at number 6.
Oops. Okay. Okay. Hold on. I gotta.
I'll be right back. I just wanted to get some water just really quickly.
Okay.
Thank you.
Call from Englewood PO. Call from
Justin?
Alrighty, I'm back.
Okay. See if you can follow what I'm writing up here.
Gotcha. This is number
6.
6.
They're giving us, it's a normal distribution curve, which I've drawn, has a mean, which is x sub z, that's what mean is, of 5, and it has a standard deviation of 1/2 inch.
Yes.
So notice my label here. 5 is the mean. 5.5 inches is 1 standard deviation to the right. 4.5 inches is 1 standard deviation to the left. What percent of the data falls within 1 standard deviation of the mean?
1 standard deviation. Is it like 12% or something?
68. Here are the figures.
Oh, I was thinking between.
1 standard deviation is 68%. 2 standard deviations is 95%. And 3 standard deviations is 99.4%.
Okay.
Now, they're always symmetrical. So the area that I've drawn here is 1 standard deviation. That means it's 68% of the area under the curve is here. Okay? But the question is, what percentage are from 4 inches to 5.5 inches? Well, certainly 68% are from 4.5 to 5.5, right?
Yeah.
So I need I need to go another 1/2 inch so that this is x minus 2 standard deviations. And if I label my curve, I know if this is 68%, that's got to be 34, and this has got to be 34.
But why is it 68%?
Just is. It's the definition of a normal distribution.
I don't like that.
What's that?
So I don't really like that. It's just like...
Well, it's because the standard deviation can change. It doesn't have to be a 1/2 inch. In other words, with different kinds of data, your mean is going to be different and your standard deviation is going to be different.
Yeah.
Only on Lilliputians, where their mean height is 5.5 inches, or excuse me, 5 inches tall, with a standard deviation of 1/2 inch. And what that says is that 68% of Lilliputians will be within 1 standard deviation of the mean. So 68% will be from 4.5 inches to 5.5 inches. That's 1 standard deviation.
All right.
Okay. Now, if I draw out 2 standard deviations, so this is the mean plus 2 standard deviations, which would be 6 inches. This is the mean minus 2 standard deviations, which is 4 inches. I know that between 4 and 6, 95% of the data, and it's also evenly distributed. So I've got 13.5 that goes there, and 13.5 that goes in that zone.
Okay.
Notice that if you add up those 4 numbers, you'll get 95%. And that would fit. 95% of the data is going to be within 2 standard deviations of the mean.
Okay. Just hold on a second. On your graph, so we have 5, 5.5, and then 4.5.
Uh-huh.
And then there's an x plus that 2 circle thingy.
That's
and then there's a 4 on the other side.
right, and that's x minus 2 sigma. Not sigma, standard deviations. That little thingy is standard deviation.
Okay.
Okay? So, you see why 68% of the data is within 1 standard deviation. That would be from 4.5 to 5.5. That's 1 standard deviation from the mean. Okay?
Uh-huh.
95% of the data would be between 4 and 6, because that's 2 standard deviations from the mean.
Yes.
The amount of data that's going to be between 4 and 5.5 is the sum of this one, that one, and that one. So it's 68 plus 13.5. 81.5% of the heights will be between 4 and 5.5.
Okay, just one thing. Like when it said, okay, so what we're trying to find is like the percentage between 4 and 5.5. So what we have is it's like the x minus 2 sigma all the way to the x plus sigma thing. So we're adding 13.5 plus 34 plus 34.
Yes. What you really want to remember on these problems is these 3 numbers up here at the right. Know that 1 sigma from the mean, 68% of the data, that causes it to be split to 34 and 34.
Yes.
2 sigma is 95%. That means it has to be 95% from there to there, which these 2 zones have to be 13.5% each.
From 4.5 to 5.5, it's 68%. But then what makes it like 4 to 6, what makes that 95% is because like from 4 to 4.5 is 13.5%, and then 5.5 to 6 is 13.5%, and you add all of those together.
Exactly. If they said, what percentage of the people are between 4 and 4.5 inches high? 13.5%.
13.5%.
So the key to answering all of these questions is to be able to draw this curve and label each zone. Now, there's another zone, 3 standard deviations. x minus 3 of those. And there's another zone up here that would be the mean plus 3 standard deviations.
Yes.
Well, now I know that total from here to there has to be 99.4%. So this has got to be 2.2. This got to be 2.2. Now I could answer even more questions. I could say, what percentage of the people are between 3.5 and 4.5? Well,
Yes.
that would be 2.2 plus 13.5.
Because that was...
Make sure your horizontal chart is labeled in numbers, but that you know what those numbers mean. In other words, the 4.5 is the mean minus 1 standard deviation. 4 is the mean minus 2 standard deviations, because they told you a standard deviation was 1/2. In other words, part of the information they give you, that is 1/2 inch. And the mean is 5 inches. So between those two pieces of information, we pretty much have a really good idea to answer all of these questions.
Yeah.
Now, let's say that data was not true. Let's say that 68% of the people were not between 4.5 and 5.5 inches tall. Well, that means that the standard deviation was not 1/2 inch. In other words, most things follow a normal distribution. And a normal distribution is defined as the mean is the middle highest point, and 1 standard deviation to the right and 1 standard deviation to the left is 68% of the area under that curve.
Yeah. Oh.
In other words, when you ask, you don't get why a standard deviation is 1/2 inch. It's because they did all the math. In other words, they analyzed all of the heights of the people, all of the Lilliputians. They did the math, worked it out so that the mean was 5 inches and the standard deviation was 1/2 inch. They figured all that out with complex formulas. The formula for standard deviation is pretty complex. They don't usually make you do that. Figure out what it is.
Yeah.
What they do want you to know is this stuff. In other words, how to apply the 68%, 95%, and 99.4% to the zones under this normal curve, like I've done there. And you'll notice that you had to have everything on here. I needed the numbers 4, 4.5, 5, 5.5, and I also needed to know that the 4.5 was the mean minus 1 standard deviation, and the 5.5 was the mean plus 1 standard deviation. So that's why I have 2 labels at each point on this curve. It's because we need to know that the 4.5 mark is 1 standard deviation below the mean. Okay?
1/2 inch X.
Looks like the very next question is a similar one. Do you need to do 7? Let's do 7, because I think,
yeah, let's do 7.
It'll clear up some stuff here. Now, here's what I'm going to erase, the numbers. I'm going to leave nothing else changed. Oop, didn't want to erase that. I wanted to erase this 6 right there. Okay, so that's my curve right there. Okay, now they're going to give us a different mean and a different standard deviation. So the mean they give us is 75, and the standard deviation is 8. So the mean plus 1 standard deviation has to be 83. The mean minus 1 standard deviation is 67. You with me?
Yes, sir, I am with you.
Okay. What percentage of the test scores are less than 87? Well, let's see. If I go to the 87, that's a half of a standard deviation, right? In other words, I got to go 4 more units to the right.
Yeah.
So that's 87. And if I draw a line right there, this zone is now down to 6. Instead of 13.5, it's 6.75. With me?
Yes.
When I say that, I mean this area right there is 6.75%. So to answer their question, what percentage of the scores are less than 87? I just got to take 99.4% and subtract off those two zones.
Really?
Because the rest of it is 90. In other words, the total area from here to here, which is 3 standard deviations, represents 99.4% of the data.
Huh.
So it's all I got to do is take 99.4%. Nah, that's not the way I'm going to do it. I know that 50% of the data is to the left of that. Correct?
Yes.
So what I've got is 50% plus this area, 34%, plus that area, 6.75%. That's my answer.
Okay.
That is 90.75% of the data lies to the left of the number 87. Now the reason I did it differently, I used 50%, is because this thing goes way out and you eventually get 100% of the data. And it's important to know that 50% of the data lies to the left of the mean and 50% lies to the right. So I know that if they'd have said, what percentage of the scores are less than 75, the answer is 50% without doing any more work.
Oh, that's nice. I don't even have to show any work.
Well, you know what I'm saying. In other words, I don't have to worry about these endpoints. 3 sigma only covers 99.4%, not 100%. However, I do know that 50% of the data is to the left of the mean. So all I have to do is add that section, which is to the right of the mean, and this little tiny section that's between 83 and 87. Add those three numbers, 50%, 34%, and 6.75%, and you got your answer, 90.75%. And all of these problems are just like this. You have to match up the horizontal scale with the information they've given you. In other words, label the mean, then go out 1 standard deviation, which in this case is 8, which means 83. Yeah. That's the mean plus 1 standard deviation. And so forth and so on.
Okay.
Okay?
These aren't that bad.
No, they're not bad. Sometimes it's just the way that you have to look at it. In other words, when I was trying to do this, I was going to add up this 6.75% to 34, to 34, to 13.5, to 2.2, but then I got a tiny percentage over there that I don't really know what it is. But you do know what it is. It's like 0.3. Because I know that all of this area to the left of the mean has to add to 50%. And right
Yes.
now it doesn't quite add to 50%. So why worry about what that is? Just start with 50% and add the other areas to it.
Yeah. I have a question.
Huh?
So at this 83 we have right here, right in front of the 75, why is there an 87 like next to it? Because I mean, that's not adding 8.
It's half of a standard deviation. It's 4.
It's half.
Yeah. So I split that zone in half. In other words, the original zone was 13.5%. Okay? Going from the mean plus 1 standard deviation to the mean plus 2 standard deviations is this whole area right here. It's this whole area. In other words, up to 91. That would be 13% zone.
Really?
Since 87 is halfway there, I split it in 2 and called it 6.75% instead of 13.5.
So that's where we got the 6.75.
Right. Is half of that zone from 83 to 91. In other words, from 83 to 91 is 13.5% of the data. So from 83 to 87 is 6.75% of the data.
Why did we put, but why did it say on? Oh, it's when it says test scores are less than 87, that's why.
That means everything to the left of 87. So I need to know what percentage of the data is going to be left of 87. And the one thing I know for sure is that 50% of the data is to the left of 75.
Yes.
So all I got to do is add this zone from 75 to 83 and add the zone from 83 to 87 to that 50%. And that's what I've done down here.
That makes more sense.
Well, okay, I think this is probably the last problem on statistics, isn't it? I don't see any more on this page. I don't really want to erase it if we're going to have more problems, because then I'll just have to redraw it.
I don't think so.
Okay.
Yeah, I think that's the last one.
Okay. What's the next problem you need to do?
I have number 10 right there.
Yeah, you know how to do 8 and 9?
Yes, those ones are easy.
Okay, yeah, they are. 8 is 10 minus 7.
Yep.
Okay, so number 10. A parabola has its vertex at 2, minus 1, and its focus at 2, 4. What do I know about this parabola? Does it open up, open down, open to the right, open to the left?
Does it open up?
Yes. In other words, the focus is always on the same line as the line of symmetry. The line of symmetry goes right down through the vertex, like that. And the focus is always on that line. So if my focus would have been over there, then it would have been a parabola that opened to the right. You with me?
Yes, I am.
Okay. So that's what we know. Let's see. And let's label that 2, 4. And this was 2, negative 1.
Yes.
What is P?
I don't know.
P is the distance. It's called the focal length. And it's the distance from the vertex to the focus.
Okay.
Okay. Now, first of all, I need to know my general equation. My general equation for this parabola, because it opens up or down, is this. 4p times y minus k equals x minus h squared. That's your general equation for a parabola when talking about conic sections.
Uh-huh.
I hope they've given you this one, because otherwise this isn't going to make a lot of sense. But we can do it both ways. It's just I need you to tell me which one they use in your school. Because about half the schools use this format and the other half use the standard Vertex format. Along with telling you that A is equal to 1 over 4p.
Yeah, not exactly.
This is definitely the preferred format. I would say that of all the high schools I work with, 80% of them use this format.
Really?
Yeah. So
okay, let's use this one.
Let's use this one, and then I'll go back and use the other format and show you that it produces the same thing. If the format's the only one you've dealt with. Okay. Now, let's see. Is that all the information? I do. That's all I need. Okay. So, they want the equation of the parabola. Well, I know what K is, I know what H is, and I know what P is. So, coming up with
Wait. Hold on a second. Go back to P. I'm sorry.
P is the distance from the vertex to the focus.
Vertex to the focus. That would be 5.
Okay. So it's 20 times y plus 1 equals x minus 2 squared. There's the equation of the parabola.
Oh, 4p. So we got the 20 from the 4 times the 5.
Exactly.
20 times y plus 1. So, wait. Y minus k. Where's k is negative 1 right here of the vertex?
Uh-huh.
K is the y axis of the vertex.
K is the y coordinate of the vertex.
Y coordinate of the vertex.
Uh-huh.
H is the x coordinate of the vertex.
Correct.
4p.
So if you can calculate P and you have the vertex, that's all you need for the equation is P, K, and H. Okay?
Okay.
Now, let me just, in case you don't use this format, here's the other format. This is the one, your more common vertex format that they teach you when they first start teaching you about parabolas. It's that format. Okay? And the provision is that A equals 1 over 4p, which makes P also equal to 1 over 4a.
Oh, this is the one we do. That's the one that we've done.
The one on the right?
Y equals a times x minus h squared.
Okay, but everybody gets that. In other words, all school systems get taught this. This is the very first vertex format that they teach. But once you get to conic sections, they change it to this one over here on the left, unless they don't in your school. Okay, I'll assume we can work with that. Either one, you can come up with the same equation, is what I'm trying to say.
Mm-hmm.
Notice, if A is equal to 1 over 4p, then this becomes y equals 1 over 4p times x minus h squared, and I'm going to take this k and put it over here on the left side, making it y plus k. You with me?
Well, okay, P equals 1 over 4a, y equals 1 over...
A equals 1 over 4p. Let's use that one.
Okay.
So all I did was I moved the k to the left, and I changed a into 1 over 4p.
So we're not worrying about P equals 1 over 4a right now?
No. It's a true statement, but it's not helpful here. Okay?
Okay.
So all I did was move the k over and change the a to 1 over 4p. Now, what happens if I multiply both sides of the equation by 4p? I get this. Which is the one on the left. This one over here.
Oh, wow.
So they're both the same, is what I'm trying to say.
Well, but you have a y plus k on the one on the right.
Well, on the one on the right, it's minus k. That's the vertex format. But if I move the k over to the left, it becomes y plus k, does it not? It's actually plus k there. And I made a mistake. I apologize. It is minus k. In other words, the standard vertex format is that. It's plus k. So if I'm going to move that k to the other side, I got to subtract it.
Yes.
Nothing like me having my sign wrong to confuse the student. Okay. Now we good?
Yes.
And now you'll notice that I get exactly the same equation that I used to start with. The reason this is the preferred equation is because I'm not so concerned with what A is, but I'm really concerned with what P is. I couldn't care less what A is when we're talking about parabolas and we're talking about where is the focus and where is the directrix. That is completely dependent on P. So that's why they convert this standard format to the format that has P in it. Is because we're always trying to solve for P or we're always given P. They don't give us A. They didn't give us A. They gave us P by telling us where the vertex was and where the focus was.
You're right.
So
Okay.
that's why I believe that even your school probably uses this format here.
Yeah, I think so.
Okay? And using that format, I was able to come up with the equation super easy because I knew P was 5. Going from -1 to 4 is 5 units.
Okay.
Okay?
So
Now, let's finish the question. They want to know not just the equation, which we've got up there, but they also want to know the axis of symmetry and the directrix. Well, what's the axis of symmetry?
y equals 2.
X equal to.
X equals 2. Okay.
Remember, vertical lines are always x equal. Horizontal lines are always y equal.
Okay.
Speaking of horizontal lines, the definition of the directrix is an imaginary line that runs perpendicular to your axis of symmetry and that is the same distance from the vertex as the focus is. Let me draw it a little bit more accurately. That's not a very good.
Oh, so it's 5 away.
Yes. So what is the line that is the directrix?
It would be 0. Okay. It would be y equals -6.
You got it. That's the directrix. Now, you don't see the directrix. It's an imaginary line. But the true definition of a parabola is the locus of points that are equidistant from the focus as they are from the directrix. Those two distances are always the same, no matter where you're at on the parabola. If I go to the vertex, it's 5 away from the focus, 5 away from the directrix. If I go up to a point like that, whatever that distance is there, same distance to there, even though it doesn't look like it from my picture.
Really?
That is the true definition of a parabola. It's the locus of points that are equidistant from a focus and a directrix. as opposed to it's the graph of a quadratic, which is kind of the old definition of it. Yeah, when you start talking conic sections, parabolas and ellipses and hyperbolas are all about the focuses. So that's why I think this is the better formula, because it's got focus built right into it. That's what P is the focus.
Yes, sir.
So yeah. If they were to give you that equation and say, what is the focal length, you would know that 20 is equal to 4P. So 20 equals 4P, therefore P is 5. The focal length is 5.
Okay.
Makes the focus 5 units above the vertex.
Yeah.
All right. And I think that's all they wanted there. Write the equation, directrix, and the axis of symmetry, and then graph it. We've done all 4 of those.
Okay.
What next?
What do we have next? Oh, we have
12 is what to do. If it's not on your list, let's do 12.
Yeah, I was saying. Oh, can we do 11 first, actually?
Uh-huh. Yeah. 12 is like, you're liable to get a lot of problems like 12, where they give you this long polynomial. Notice what 12 is. It's just a polynomial equation.
Yeah.
You got to tell whether it's a parabola, a circle, an ellipse, or a hyperbola, and whatever it is, come up with the equation of it. So this is a very, very common question for conic sections.
Okay.
In fact, you might get 2 or 3 of these, depending on whether you've studied all the conic sections. If you've only studied parabolas and circles, then they're probably not going to give you a lot of these. But once you've studied all four being parabolas, circles, ellipses, and hyperbolas, those are the 4 conic sections. Once you've studied all 4, they all are polynomial equations like this. They're just slightly different from one another. And you can tell what it is by knowing the general equation of each of those 4 conic sections. But let's look at 11. We can take care of 11 quite easily.
Sounds good.
Log functions always look just like that, regardless of the base. In other words, that could be y equal log base 2 of x. It could be y equal natural log of x. It could be y equal log base 90 of x. The reason they all look the same is because they all go through the same point. What is that point?
1, 0.
And they are all asymptotic with the y-axis, and they all rise very, very slowly, almost like there's a horizontal asymptote there, but there isn't. In other words, that thing will eventually go to infinity vertically as we go to infinity to the right.
Yeah.
Okay, so this curve, log base 9 of x, is going to look just like most every log equation or log curve. If I just drew a log curve and gave only one point and didn't label the grid, you wouldn't know what it was. You'd say that's a log curve, but I don't know what base.
Yeah, exactly.
If I want a base, if I want a log curve that fits the base 9, then I know that the log of 9 is 1, right? The log base 9 of 9 is 1. So I know that when x is 9, y has to be 1.
Okay.
Now I've got a grid on there, and this curve is unique. This is not the same curve as the log base 2 of x. Because the log base 2 of x, when x is 2, y is 1. So this is now specific to y equal log base 9 of x. The only thing that differentiated is the fact that I've put another point on my X grid and I've started to label the Y grid. So that this point is only for this curve. It's not going to be the same point on a log base 2 of X.
Huh. Okay.
Okay? All right, let's look at 12. They do the hard work for you. They tell you it's an equation of a circle. Okay?
Yes.
Now, the reason they do that is because they haven't taught you about ellipses and hyperbolas yet. So they can't really ask you, what is that the equation of? The reason
Oh, that's not
the
cool.
equation of a circle is because the coefficients of the x squared and the y squared are the same. And they are being added. I've got a 3x squared plus a 3y squared. If I see that, that's all I need to know it's a circle.
Okay.
If those numbers were different, it would be an ellipse.
Oh.
If the y squared was being subtracted from the x squared, it would be a hyperbola.
Yes.
So, they're telling us it's a circle, and they want the equation. Well, what's the general format for the equation of a circle?
The general format for the equation of a circle.
Starts with that.
X minus h squared plus y minus k squared equals 0.
Equals r squared.
Oh, yeah.
The radius of the circle squared.
Yes.
Okay? So we got to take this big long polynomial and put it into this format before we know where its center is, before we can graph it, before we know what its radius is. And the way we'll do that is to complete the square. Okay? So, the way we complete the square is we group the x terms together. Like that.
Yeah.
Leave room to complete the square. We group the y terms together. Leave room. And on the other side is the radius squared still. Whoops. Excuse me. On the other side is 24. Right? I'm taking that 24 and I'm moving it to the right.
It is fudge, this is 12. Yes, it would be 24.
Okay. Now, here, let me write this a little nicer. I'm getting closer to my format. If I can complete the square, I'll have x minus h squared plus y minus k squared, right?
Yeah.
However, you can't complete the square if the coefficient on the squared term is other than 1. So I got to factor out a 3 from both of these things.
Yes. Factor out a 3. So then that would leave...
Tell me what to write, the rest of it.
X squared minus 4x.
And leave room to complete the square. Go ahead and complete the square on that one.
Plus 4.
How much did I just add to the left side of the equation?
Nothing.
I added 12. I wrote in a 4 that's multiplied by a 3.
Yes.
So I just added 12 to the left side of the equation, means I got to add 12 to the right to balance it out. Now I haven't changed it. The whole idea is to not change it. Okay? And I got to do the same thing for the y term. I'm going to factor out the 3, leaving y squared plus 6y. Now complete the square there.
Plus, no, that would be... Is that plus 9?
Just take half of that number and square it. That's all.
Yeah.
It's always being added. So how much did I add to the left side now? Just then.
You added 27.
So I got to add 27 to the right. Now it's really taking on the shape of our general equation.
Yes.
Okay. If I add these three numbers up, I get 63, I think. Let's see. Yeah, 63. Let's get rid of that 3. I don't like that 3. Our general equation does not have an A in front of it. So
True.
I'm dividing both sides by 3. Leaving and on the right, when I divide that by 3, I got 21. Okay? Now we're really close to the format. So all I got to do is figure out how to write this x thing in terms of an x minus h. Well, what is it?
X minus 4.
No, it's got to be x minus 2. It's whatever you got when you took half of that coefficient. Always.
Oh.
Always. That's what it is. So what's this one, the y?
Would be y minus 4.5.
Plus. And it's not half of 9, it's half of 6.
Oh, oops.
Remember, you took half of 6 and then you squared it. Well,
So it's 3.
So it's 3, and that's squared. In other words, x minus 2 squared is that polynomial. Y plus 3 squared is that polynomial.
Yes.
And they're all equal to 21. Well, now I have it in perfect circle format. Where's the center of my circle?
That will be 2, negative 3.
What's the radius of my circle?
21?
Root 21.
Oh, root 21.
That's r squared.
Oh.
And the center and the radius are the only two things you ever need to know about a circle. There is nothing else about a circle that is important other than its center and its radius. In fact, if we look at the question, they can't possibly ask much other than that. Complete the square to change this equation to standard form. We did that. Find the radius and the coordinates of the center of the circle. We did that. Graphing the circle, I'll leave that up to you.
Okay.
Just start at the center and make a radius of root 21 and go from there.
Gotcha.
Okay.
Boom.
That's a good one to stop at. Those are kind of fun, especially when they give you a whole series of long polynomials and you got to first figure out what's what, you know. In other words,
yeah.
This is a circle only because 3's match. Make that 3 a 4 and it's an ellipse. Make that a minus 4y squared and it's a hyperbola. And you have to come up with each equation in the same method by completing the square. So whenever they give you a long polynomial like this, no matter what conic section it is, you got to complete the square to solve it.
Okay.
Okay?
Alrighty.
All right, Justin. You have a good evening, the rest of it. Talk to you next time.
Thank you.
All right. Bye-bye.
Appreciate it.
Sure.